Hi there, this is the final part of the mechanics multiple choice part 1. So again, as always, just attempt the question and then I'll talk you through the answers. Question 31, the mass of fuel in a racing car decreases during a race. As a result, the lap time decreases. Which of the following could explain this decrease? Now the answer for this one is C. The maximum acceleration and deceleration are greater. So if we look at Newton's second law, F equals ma, the force from the engine will be constant. However, if the mass decreases over time, the acceleration and subsequent deceleration of the car will increase. Question 32. A deep space probe travelling at a constant speed is briefly acted on by a force at right angles to its motion. What is the effect of this force on the forward speed and sideways speed of this probe? Space is obviously empty, so travelling forward, there will be no change. So the forward speed would be completely unchanged. However, after experiencing a force at a right angle to its motion, the, so to speak, sideways speed of the space probe would increase. So the answer is C. Nothing is happening in the forward direction as no forces are acting in that direction. Number 33. A golf ball was hit from the surface of the moon. The time of flight is 4 seconds. What is the best estimate for the maximum height reached by the ball? And it gives the acceleration due to gravity on the moon as 1.6 meters per second squared. So for this question, the key to this is the time of flight is 4 seconds. So that means that it takes 2 seconds to get to its maximum height and 2 seconds to fall from its maximum height. The falling is what we're going to work with. So I'm going to write sue that. We'll take down as positive because we're only looking at downwards. The displacement is what we're looking for is S, or you could call it height. Completely up to you. The initial speed, at the top of its flight, the vertical speed is going to be 0, or the vertical velocity. So 0 meters per second. The final velocity, not sure, but we could figure it out, but we're not interested in this example. Acceleration due to gravity, so we're going the same direction. Gravity on the moon, remember, is 1.6 meters per second squared. And the time would be 2 seconds. So we need an equation that doesn't have V. So S equals ut plus half at squared. Obviously the initial vertical speed is 0. So we're left with S equals half at squared. Then we just put our numbers in. So 0.5 times the acceleration 1.6 times 2 squared, which is 4. Put that on your calculator. You get 3.2 meters. So the answer is A. Next, we're going to look at this question. A girl jogs in a straight line for 30 seconds, turns around and returns to a starting point 20 seconds later. What is the average velocity and average speed? The average velocity, so velocity would be change in displacement over the change in time. The girl jogs in a straight line for 30 seconds, but then turns around and goes back to the starting position. So the displacement is the total displacement is the distance from your starting position in a straight line. The displacement is 0, so the velocity, obviously 0 divided by anything is 0. So that leaves us with A or B. Then we just need to figure out the average speed. So average speed is distance divided by time. And all we need to do is figure out the distance. The girl jogs at 2 meters per second for 30 seconds, turns around, goes back to where she started. So distance is simply speed times time. So that would be the 2 meters per second for 30 seconds, which is 60 meters. Then the girl returns back to her starting position. So 60 times 2 gives a total distance of 120 metres. Then to get speed, we just need to divide the 120 metres by the total time. The total time is 50 seconds. So 120 divided by 50 seconds gives a speed of 2.4 metres per second. So the answer is A. Let's move to the next one. So to zoom this out a bit. So the velocity time graph for a falling object is shown. Which of the following shows the corresponding acceleration time graph? To let you have a go at that one. So there's the velocity time graph. Which of those is the corresponding acceleration time graph? The way that we tackle this question is that the gradient of a velocity time graph is equal to the acceleration. So as you can see, if we put these tangents, or I attempt to do these tangents, to the curve, we can see that the acceleration starts off high and then is decreasing to 0. So the only graph that resembles this is graph B. So the acceleration starts higher, gradually reduces until it hits 0. So the answer to number 35 will be B. And that's the end of Mechanics Multiple Choice 1. Thank you for listening.